In this lesson, we're going to discuss complex numbers, and that has to do with imaginary numbers, which occur when we have an even root of a negative number. And the easiest way to deal with these is to write the imaginary numbers with the I format, and to do that first before you actually break a radical down into prime numbers. In this case right here, we have this even root, a square root of a negative number. So the very first thing I would do is to rewrite that as the square root of 32i. Now when I write the I, that is that negative sign right there, but it's going to be on the exterior of the radical, so you can put it behind the radical or in front of the radical, which does not matter. But we do need to break our 32 down into prime numbers, the smallest prime number being 2. So 32 divides by 2 16 times, 16 divides by 2 8 times, 8 divides by 2 4 times, and 4 divides by 2 2 times. Because we're looking at square roots, we're looking at pairs of prime numbers. So we have actually 2 pairs of 2's. For each group that we circle, we can take one of those out front because we're taking the square root of a perfect square, which is 4. So if we have 2 2's out front, that's actually going to be 4. Whatever we've not touched, which in this case right here is this 2, goes back on the inside of the radical, and the I is on the exterior. So you can either write it behind the radical or you could write it before the radical. Either answer should be sufficient. In this case, again, you need to write your imaginary number notation first. So the negative sign's on the outside. There's no problem with that. The problem is that we have the square root of 121 with this as being our I. That's just rewritten as an I. So in this case, we need to take the square root of 121, which is actually 11. So the negative sign and the I actually follow along with this. In this next case, again, it's so important to write the imaginary notation to begin with. So we have the square root of 11i times the square root of 3i. So we can multiply the square root of 11 times the square root of 3 because they are the same root, which gives us the square root of 33. And I times I is actually I squared. And in mathematics, I squared is actually equal to negative 1 because it's the square root of a negative 1 times the square root of a negative 1. So therefore, I squared could be substituted with a negative 1. And when I multiply that together, actually my negative is going to be transferred to the front before the radical. And that would be my final answer. So just as a mathematical note, I squared does equal to 1, and all we did was substitution right there. In this case, I've got an imaginary number on bottom, but I do know the square root of 49, so I am going to take that when I rewrite this. So I've got the square root of 49, which is 7, and then I have the square root of 10i. Now there are 2 things wrong with this answer. First of all, we have a radical in the denominator, and second of all, we have an I. So remember from a previous lesson, we're going to multiply whatever our problem is in the denominator. We multiply the numerator and the denominator by whatever the problem or the issue is. So in the numerator, I have a 7, a square root of 10, and an I. In the denominator, the square root of 10 times square root of 10 is 10. I times I is I squared. But remember that I squared is equal to negative 1, so I actually would have a negative 10 in the denominator, and it's more appropriate to put the negative sign, place it either to the side or in the numerator, either one. And I'm just going to leave the 10 in the denominator and move my negative sign to the numerator. So that would be my final answer. In this next example, I can see that I need to subtract these 2 terms, 2 sets of terms right here. I do not need my first set of parentheses, so I'm going to drop my parentheses. In the second set, I need to distribute that negative sign to both terms, so that's going to become negative 6, and this is going to become a positive 8i. And then I'm just adding like terms since, from what we've done at the beginning of the book, which was chapter 2. Negative 2 plus negative 6 is going to actually be negative 8. That's my real part. My imaginary part is I'm going to add that together. Negative 4i plus positive 8i is positive 4i. And you always want to write your real part first and your imaginary part second to be mathematically correct. In this next case scenario, we have to square a binomial. And when we square something, that means we need to write it out 2 times, as is. Don't change any signs on this. And then what we do from that is actually FOIL it out. So we're going to say 6 times 6, which is going to give us 36. 6 times negative 3i, which is negative 18i. Inside is going to be negative 3i times 6i, which is negative 18i. And the last term is negative 3i times negative 3i, which is positive 9i squared. But now remember, this is 9 times negative 1, so really that's just negative 9. So I can add 36 and negative 9 together, and that's going to give me a positive 27. And then I can add negative 18i and negative 18i, which is negative 36. The I stays the same because that was your like term, and this is the final answer. In the next case, I have a problem because I do have an I in the denominator, but I have two terms, so that's where that term conjugate comes back up. I cannot cancel anything, so don't start trying to cancel things out. I have to take the conjugate of the denominator, which is the denominator with the middle sign changed. And whatever I do to the numerator, or multiply by the numerator, or multiply the denominator the same way. I do have to FOIL this out, so I have 6 times 6, which is 36, 6 times 5i, which is 30i. Inside is going to be positive 30i, and the last term is 5i times 5i, which is positive 25i squared. And if I want to, 25 times negative 1, that's negative 25. I'm going to rewrite that. On the bottom, I have to do the same thing. I have to FOIL it out. 6 times 6 is 36. 6 times 5i is positive 30i. Inside is going to be a negative 30i. And the last term is going to be a negative 25i squared, which negative 25 times negative 1, that becomes positive 25. Also, my 30i's cancel on bottom only. So in the numerator, I have 36 minus 25, which is positive 11. 30i plus 30i, which is going to be positive 60i. And in the denominator, I've got 36 plus 25, which is going to give me a positive 61, which nothing will reduce, so I will just leave it as is as a final answer. In this next case, we have imaginary numbers that are larger than I squared. So if we could break these into I squares, it would make it a whole lot easier to simplify, because in the end we only want to see a real number or an imaginary number, nothing larger than an I. So in this first case, if I broke this down to I squares, if I've got 10 I's, then that means if I broke them into pairs, I would have 5 groups of I's, because 2 times 5 is going to give you 10. Well, I squared is negative 1. So all I've done is where I squared was, I put a negative 1. That 5 is still an exponent. So if I simplified it now, if I have 5 negative signs, I still have a negative sign. If it's an odd amount, it's negative. If it's an even amount, it's going to be positive. And 1 times 1 times 1 times 1 times 1 is still going to be 1. So that's as far as I can simplify it. Now, in I to the 15th, I'm still going to break them down into I squares. If I have 15 I's, that means I have 7 pairs of I's with 1 I left over, because this is really 14 I's. There's my 15th I right there. And then I'm going to simplify I squared, and we'll leave the 7 as the power and I out, that's on the outside, but the I squared I'm going to substitute for negative 1. If I have 7 negative signs, it's still going to be negative, and 1 times itself 7 times is still 1, and then I've got an I running around. So you can either simply write it as negative I or negative 1I. If I have 40 I's, again, going to break it to I squared. If I have 40 I's, that means I've got 20 pairs of I's with no I's left over, because there's my 40 right there. So I'm going to leave the 20 on the exponent. I squared is negative 1. If I have 20 negative signs, it's going to be a positive, and then 1 times itself 20 times is just going to be a positive 1.